So we start out with something called the factorial symbol. And the factorial symbol is just an exclamation point. That's all it is. It's an exclamation point. And what that means is this. You define 0 factorial to be 1, and that's by definition, and 1 factorial is 1. That's also by definition. Then we come in, and in general, for n greater than or equal to 2, and n has to be a positive integer, so this guy is a positive integer. A positive integer, n factorial is n times n minus 1 times dot 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 times 3 times 2 times 1. You start with the number n and then you multiply it, time the numbers sequentially times each other as they go down. So example, 2 factorial is 2 times 1, which is 2. 3 factorial will be 3 times 2 times 1, which is 6. 4 factorial will be 4 times 3 times 2 times 1, which is 24, and so on. So if I look at 9 factorial, 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Start at 9 and work your way down, and you'll find that that 9 factorial is 362,880. And if I'm doing 5 factorial times 8 factorial over 3 factorial, this would be 5 times 4 times 3 times 2 times 1 multiplied 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. By the way, when I took probability and statistics, this is what I did all the time. 3 times 2 times 1. So what you normally do, 3 times 2 times 1, 3 times 2 times 1. So this is 5 down to 1, and then 8, 7, 6, 5, 4. And so this is going to come out to be 5 times 4 times 3 times 2 times 1 times 8 times 7 times 6 times 5 times 4, and it becomes 806,400. Now, factorial is on your calculator, so from a calculator point of view, it's under Math, and PROB, or PRB, excuse me, PRB. It's Math probability, and then it'll be under the number 4. So on my calculator, it's under Math, and let me move this up so you can see it. It's under Math, and then you'll go over to probability, and then there's 4. So if I wanted to have 9 factorial, I'd have 9 Math probability 4, and then it's 362,880. Now, for this guy that we did, which was 5 factorial times 8 factorial divided by 3 factorial, if you do it all at one time, you'd have to put this in parentheses to make sure everybody lined up the way it was supposed to line up. Or you could do the numerator and then the denominator. So, parenthesis 5, Math probability 4 times 8 math probability 4 divided by 3 math probability 4. And so there is 5 factorial times 8 factorial divided by 3 factorial. And then there it is, 806,400. If you're going to take any probability or statistics at all, you're going to be using that particular function in your calculator, because we use this for counting how many ways something can happen. So it's like I would say to you, I've got 10 digits and I want to form, how many numbers can I form using each digit only once? That's 10 factorial. Because if I'm in a combinatorics, and that's the topic, is combinatorics, I'd have 10 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm not repeating, so I'm only using them once. How many ways can I choose the first, which is 10? How many ways can I choose the second, which is 9, because I've only used one of them? How many ways can I choose the next one? 8, 7, 6, 5, 4, 3, 2, 1. These are all multiplied together. And it says if I had a 10-digit number where I could use only, each number you could only use the digit once, it would be 10 factorial. Which is 3628800. So there would be, I can come up with over about 3.5 million unique numbers using each digit only once. So once I've used the digit, I can't use that digit again. So when you, each number, that's the way it would operate. So that's how many there would be. That's how they determine how many zip codes you need, how many prefixes for telephone numbers you need, or even how many telephone numbers will go with a particular prefix. The downside for the telephone number thing, by the way, is the fact that what they did was they broke the telephone numbers down, and they put them in blocks. So each area got a block, and that means some areas are not going to use all those numbers. So that then they'd have to add a different area code, and that became a problem. So, wonder why we have so many area codes. Well, you got a lot of numbers out there that are also not being used because certain areas got blocks of numbers. Now, what we're going to be interested in is the idea of something called a sequence. And a sequence is a function, because remember, college algebra is the study of function, whose domain is the set of positive integers. And this is where things are going to be a little bit different. Positive integers, 1, 2, 3, 4, and so on. We also call these guys the counting numbers. And it'll become clear as how this is going to work. This is a sequence, 2, 4, 6, 8, 10, separated by commas. That's a sequence of even numbers, 2 through 10, 4, 7, 11, 16, 22, and 29. Now, what you need to understand is the list itself. If I were looking at X and Y, the list itself, these guys are the Y values. So if we're going to put in X and get out Y, these would be the Y values. Then you're going to say, what are the X values? Well, the X values are the position in the list. So that's position 1, position 2, position 3, position 4, position 5. These are the X values. We call them N, by the way, rather than X. And this is the position in the list. What's most funky about this, more so than anything else, is the fact that we're not talking about my domain being all real numbers, and we're talking about positions in the list rather than kind of like, we're still putting in X and getting out Y. So in this case, position 1 has a 4, position 2 has a 7, position 3, position 4, position 5, position 6. Now a position, now if I look at this guy, a position is denoted by A or some other letter. It could be A, B, C, D, E, F, G, any letter of the alphabet. And then the position number is a subscript. So I would say that in this list right here, A sub 1 equals 4. If X equals 1, Y equals 4. A sub 2 equals 7. X equals 2, Y equals 7. A sub 3 equals 11. X equals 3, Y equals 11. A sub 4 equals 16. X equals 4, Y equals 16. A sub 5 equals 22. X equals 5, Y equals 22. A sub 6 equals 29. X equals 6, Y equals 29. So essentially we denote what we're going to plug in for the value. That's the subscript. That's the subscript. Which makes it a little bit different.